In this video, we're going to look at how to take the logical design and implement a table in SQL Server Management Studio. So in addition to column names, you will need to know the data type. You will need to know if it's a primary key, a secondary key, a foreign key, or perhaps a candidate key. You will need to know whether a field is required or not, and you may also have a reference to extra constraints that you see here in the remarks column. So let's start with the data types, which are covered in both the hands-on text and the querying textbook. So there are several different types of integers. For example, there's 1, 2, 3, 4, 5 types of integers. How do you decide which of these integer types you would want if you needed an integer data type? In addition, how would you decide between an integer data type and a data type that requires a decimal? So generally quantity, if you're counting values, those are going to be integer data types. And you should choose the smallest size that's going to fit the needs of the data. So let me give an example. If I needed to store the number of students enrolled in a certain class, tiny int is more than adequate because the range is from 0 to 255. However, if I needed to store the number of students enrolled at the college, I might have to consider small int. And that can take me up to over 32,000 values. You'll notice that the difference of these is 1 byte. So by opting for the small int, each record is going to need an additional byte just for that one field. The difference with decimal values has to do with precision instead of range. Let's go on to the date-time data types. Then the difference between these data types have to do with the range. Some of them allow a time and some don't, so the date does not store time. So suppose you needed a field that was going to store when employees punch in to start a shift. Obviously the date data type would not be correct. You need also the date and the time that they punched in. And there are several character data types. Some are fixed length and some are variable length. These data types without the N in front of it will use ASCII. ASCII requires 1 byte per character. These data types that are similar with an N in front will use Unicode instead of ASCII, which requires 2 bytes. If you're working in the US, ASCII probably is adequate. It's going to save an extra byte per character that you're trying to store. So you can use the fixed length char, the text, or the var-char. So let's look at the difference between a char and a var-char. From page 40 of our querying textbooks, it mentions that var-char is going to store the size of what is being entered into the field. For example, let's say you're trying to store someone's first name and you're going to choose var-char. And you think, well, usually a first name field might be about, at the most, 20 characters. If someone's first name is over 20 characters, it's going to truncate at 20 characters. So you want to make sure that you get this number adequate. However, let's take my name. Deborah is 5 characters. If I indicated that I wanted 20 characters for the first name, am I going to waste 15 bytes because I only need 5 bytes? I only need 5 characters instead of 20. Well, with the var-char, the database will only take the storage required and not take all of the storage. With char is fixed length. So if I indicated I needed 20 bytes and I'm storing Deborah, it will take 20 bytes even though only 5 bytes are required. So a couple of guidelines is if there is a wide variation in the size of the data being stored, then you should use var-char. It's pretty much the norm to use care when it's a fixed size. So what would be a fixed size? Zip code. Zip code is 5 bytes. So care for a zip code would be more than adequate. And finally, SQL Server has other data types, such as XML, binary, image. When you're considering the data type of primary and foreign keys that are related, from page 40 of the text, it is important that the joined columns, very important that the joined columns be consistent with types. So if you decide to make the primary key an int, my recommendation is that you make the foreign key an int also. This is going to prevent then implicit conversions when you're joining these tables with your queries. Implicit conversions cause these queries to execute much more slowly, which is something you want to avoid. When you do use the character data types, you should be aware that you're not going to use the double quotes around a literal. So here we have a character, literal, and you'll see the single quotes. If you're using one of the Unicode character data types, then you'll see that you're going to precede an N before the literal string. Here is the syntax for the create table command. You begin with create table and the name that you want to give the table. Here's the syntax for creating a table in SQL. You have the keywords create table followed by the table name. After the name of the table, you have a pair of parentheses. Inside the parentheses, you have a comma-separated list. Each item in that comma-separated list represents one field that will be in that table. You'll notice that for each field, I have 3 columns. So the first column, I've indicated the field name, second column, the data type, and the third column, one or more constraints. The first and second column are required. Third column is optional. If you don't have constraints to add, you can go with the default values. Here is the create table that you'll see in our querying textbook. This is from page 267, and you will see that there's a lot more to it. So to keep things simple, we're going to follow this format. And finally, I'm at the MSDN site, and here is the create table command, and you will see that it can get very complex, all the options in creating a table. So here is an example. We're creating a table called key, and so these are keys to different rooms in the building, and there are 4 fields. So we see 4 values in the comma separated list. In my first column, I have key code. I have field names actually, and the naming convention for this is to use the underscore instead of the camel casing or title case. Here are our data types. Here is the maximum size for the value for the key building field and the maximum size for the value of the key room field. We're using varchar. And finally, here is a set of constraints in the third column. So we're indicating that this field is the primary key, and key building and key room are required, so we have not null. Key room type does have the value of null, and this is optional. If you leave this off, the default is for this to be null too. If you want key code to behave like a surrogate key, you may want to reference the querying text at page 267. Here is from the querying text, and I wanted to indicate how the surrogate key gets its seed value. So we're creating a table, and notice this dot operation. The name of the table is categories, and this is called the schema. If you don't indicate a schema when you create a table, by default, SQL Server is going to give a schema of DBO. So in this case, there is no schema. Create table key. When I see this table in the Object Explorer, I may see DBO.key. DBO stands for database object. It's the default schema. So creating a table, production.categories, there's our parentheses, and here are our 3 lines, comma separated, so we have 3 fields. So here is our data type. They are using the Unicode for the text fields, and this is our constraints. The constraints are just in a space separated list. One field can have multiple constraints. This field will have the identity that That makes it a unique value. Even though it doesn't indicate it's a primary key, you could have added primary key here. So the identity will start at 1 and then will increment by 1 with each successive record added. So the first record will have the category ID of 1, and the next will 2, and the third will 3. I do want to add, FYI, like suppose I'm up to category ID of 25, and I go back and delete the record that had category ID of 16. The next record will not go back and grab that 16. So that 16 that got used is not going to get used again. So the next record will have a category ID of 26. Let's take a look at this one. The schema name also is production, and the table name is products. Product ID has not null and an identity. Product name, you will see all these required fields. Now let's take a look at unit price. Now unit price is data type money, and it's not null, and then an extra constraint is added, and this DFT underscore products underscore unit price, DFT stands for default. This is a name assigned to the constraint. By assigning a name to the constraint, you can use the drop command later to drop this constraint. All this constraint says is every time you create a record, if that record doesn't indicate the price, please make the unit price 0. Here we have a discontinued field that's type bit. So think of bit data type as being a true false. Think of this as being Boolean, a 0 or a 1 value. And that's a required field. Again, a constraint and the name of the constraint, so you can drop it later if you'd like to. And the default value is that it's not discontinued. Just as you can create a database using the dialog boxes, you can also create tables using a dialog box. To do this, you will use your Object Explorer, right mouse click on the database, choose New Table. There will be a dialog box for you to enter the field names and the data types. However, I am asking you to copy and paste your SQL. I do want you to know SQL. So do learn to create your tables using SQL. Now here is an example of the dialog box for creating a table. Page 42 of the querying text talks a little bit more about what you want to do if you make a surrogate key. My recommendation to keep this simple when we're getting started is to use an identity column and seed it at 1, 1. If, however, you wanted the value of the ID to start at 1,000, you can seed it at 1,000, comma 1. We'll talk about that in a minute. Let's look a little bit more about these constraints. So you can use the keyword check or the keyword constraint to limit the values that can be added in a field. With the keyword check or the keyword constraint, some keywords that you might add with the check constraints are in, like, between, and, or not. Also, you can use these relational operations. So here's an example. Suppose you have a cab, and in a cab you're only allowed to have the values new, good, poor, in repair, and sell for the condition field. So after you've indicated that you need a field called condition, and this looks like I would do probably a care or var care with about 7 for the data type, then you can add this check constraint. You literally would write check condition in, and the in operator will take a set of parentheses, and this is the set of values. However, I do see this in error, as we indicated earlier, that your string fields can only have a single quote. So there's a comma separated list, and this is the set of values that you're allowed to have within the condition field. In this example, we have a check constraint for a numeric field called amount, and amount must be greater than 0. Like is a check constraint that you can use for string fields, and it does pattern matching using a regular expression or wildcard characters. Between is also used for ranges for check constraints, and your and, or, and not are just the Boolean operations. similar to what you would do within an if condition. Primary key and foreign key are also constraints on a field. Not null and unique are constraints on the field. You would use the unique constraint when you have a field that is a candidate key or a primary key. Here's an example of a SQL statement that will create a table called cab. Create table cab. And our primary key is an integer. Notice that it's not an identity. Not null is one constraint. Primary key is a second constraint. It's just a comma-separated list. Now, you do not have to line up your columns like this. Again, SQL, it doesn't matter how you do your white space. So I'm doing it so it's more readable. I've lined up the columns. Here's a comma, and there's your make. Notice that you do not have to have any constraints. So make, we're only indicating the name of the field and the data type. There's a comma, and the next field is year. With year, a check constraint has been added. A name has not been given to the check constraint. So as you saw earlier, you can give a constraint a name. If you do give a constraint a name, you can use the drop command to drop the constraint. This one you would have to modify by altering the table. So here's a check constraint. The year must be between, and here's a low and a high value. The between actually uses the keyword and. So between the low and the high value. Here is the next field, and we're using the unique constraint. So even though the plate was not created, was not the primary key, it is a candidate key. And since it is a candidate key, the unique constraint will make sure I don't enter a second cab with the same license plate number. Similarly, you could have had a VIN number. VIN would have definitely been a unique field. Here's our current odometer, and here's decimal. So the decimal will allow one value to the right of the decimal place. Here's our cab status. Using the check constraint, again, there's no name assigned to that constraint. And cab status must be in, and here is my list of characters. I like to think of this as a set. One of these set of values. And then here is our condition, and no constraints on condition. So this cab table here is one of 3 tables, and shift driven is a heck of a table here. It's got 3 fields in its composite primary key. So let's see how we're going to create that. I also want you to notice that cab num here is a foreign key to cab num. Driver num here is a foreign key to driver num in the driver table. So we're creating our table called shift driven. The shift name, notice I'm not indicating a primary key. If I indicated a primary key here, then the shift name first. And we would only allow the cab to drive one time on first shift, which is ridiculous. So do not, whenever you have a composite key, you do not indicate the primary key at the field level. Okay? So all of these that we have been looking at, these are called field level constraints. Notice I'm constraining it when I'm defining the field. There's also something called table level constraints. So if you ever have a composite key, that constraint is going to be after the list of fields. And you can define your constraints after the list of fields, then we'll call that a table level constraint. So we have our data types, and here we have cab num, and it's integer, and it's referencing cab num. So this is making this cab num a foreign key and causing the relationship between cab num here and cab num there. Same, likewise with driver num. So this is the table name, this is the field name in the driver table. And continuing on, let's look at this primary key. This is our last field, and odometer, a comma, and then here's our table level constraint indicating that the primary key is a composite key. This constraint has not been given a name. Let's look a little more on what setting up foreign keys does as far as a constraint. When you create a foreign key, you're setting up something called referential integrity. An example is really helpful here. We have here a person's table with person ID as a primary key. This person can place orders. PID is a foreign key. Now, one person can place many orders, and as you see, PID of 3 has placed 2 orders. What referential integrity says is if I added a new record for a new order number and then assigned 4 to this record, that would not be allowed. And the reason it would not be allowed, because of referential integrity, says in order to put a 4 as a foreign key, you must put 4 as a primary key. There are some other considerations also as far as foreign keys. So what would happen if I decided to delete this record? What would happen to these 2 records? In the design phase, you make this decision. So one decision you can make is called on cascade delete. So a cascade delete says if you delete this 3, then you must also delete this 3 and this 3. Another option is called on cascade update. If for some reason you decide to change this to 99, on cascade update would say let me find all the 3's, because first I got to update those 99's. Then you can still have this relationship. What if you decide, yes, we want to delete the primary record, but let's not delete any related record? So another option is to set this to null. So if you delete this 3, you can set these values to null. Of course, you want to make sure that you don't have a requirement for that field. So the references keywords sets up that referential integrity and causes the relationship between the primary key and the foreign key. The on delete cascade, on delete set null, will do those updates as I just mentioned. If you need to make changes to the table, you can use the alter table command. This is going to modify the table structure, like changing the data types, changing the size of text fields, adding additional constraints, adding foreign keys or primary keys can all be done with the alter table command. Generally, the syntax is alter table, the name of the table. You may add a field in the data type, and I don't have this, but you can list any constraints with that data type here. You can alter table and you can delete a field name. You may alter a table and you may modify a field by adding a new data type or modifying the data type. Indexes really speed up the amount of time it takes to find records or to sort records. So by identifying fields that you commonly search on when you're trying to find a record or sort on when you're producing reports, you can really speed up the process. I have here a table. It's using array size, but the analogy is pretty similar. If you do not index a field, it's not sorted, and so accessing a particular record in the field requires a linear search. So if we have 10,000 records, it could require up to 10,000 units of looks or peeks to find that record if the record happened to be the last one. When you have indexed, then you have sorted on that field. And finding something is like finding something at the back of an book. When it's indexed, it's much faster. And it's based on a logarithmic function base 2. And so if you have 10,000 records, the most lookups will be 14. And as these numbers increase, it is a significant savings in the speed, the amount of time that it will take to retrieve these records. However, you should not index in every field. If you start indexing on every field, you'll be adding too much overhead. So there's a compromise on what you want to do here. I would consider indexing on secondary fields. Also, I would consider indexing on foreign key fields. To be honest, if it's a lookup table that's the join, there's usually not too many records, and the amount of time to find a related record won't take too long. But if it's something like person and order, and there could be a lot of records to kind of match, to find the matching and the join, then I would index on that foreign key field also. All right, so we're here in SQL Server Management Studio, and we're going to create some new tables in our test database that we created. So I'm going to click on New Query, open up the query window. Let's start with something simple. And let's create this trans table as shown in this table to the right. So as you see, make sure you are not in master. One way to make sure you're not in master is to type use test, and that will get us into the test database. And I'll type go. And now let's begin the code to create our table. And now let's begin the code to create the table. Now let's begin the SQL to create the table. Okay, so I started with the basics, create table trans, and I have a pair of parentheses. Now I'm going to go in between that pair of parentheses and start writing one line for each field that's in the table. I've added the transaction ID field. The data type is int, and right here are my constraints. There's 3 constraints. Primary key, not null, and I'm going to use an identity, and I should be starting at 100. So when I start at 100, that means that the very first record will have a transaction ID of 100. The second will be 101, etc. Now I have a comma here, and that's the end of that field, and I'll go ahead and add the next field. Okay, I have completed keying in the trans table. I've not executed it yet. And you will see that I have decided to implement the constraint on the sales price at the field level. The constraint is listed on the same line as defining the field. I decided to implement this constraint. Sales price is greater than 0 and sales price is less than 500,000 by using the between keyword. And if you recall, you will say the name of the field between a low value, the keyword and then a high value. You do not put commas inside numbers over 1,000 when you're programming. However, we do have 2 red squiggly lines. This normally is SQL Server Management Studio telling us that these objects do not exist. So I cannot create these foreign key fields as shown because I have not created customer table yet, so I can't reference the customer table if it's not created yet. In addition, I can't use work ID as a foreign key field because work has not been created. And so this is the importance of being able to use alter table. I can think through my process a little differently, and I could make sure I create these main tables first, customer and work, and then go and create the transaction table, because the transaction table is probably a linking table. Or I can go ahead and create this table, and you'll notice that I have multiple tabs. So you can have as many tabs. Every time I create the new query button, I'm opening a new tab. And if you open many tabs, you have a drop down over here, so that if you have more tabs open than you are able to page through or click through, you have a drop down of the list of all your tabs. And when you save a query, so if I save this query here, So if I decided to save this query, you will notice then the query name is changed up here. Okay, so I've taken this query and I've copied it over here, removing these foreign key constraints. And as you can see, I have executed it. And without those foreign key constraints to tables that do not exist yet, this executed fine. I did go ahead and line up these columns here. And again, white space is ignored in SQL. So you can put as many tabs or blank lines as you want for readability. So again, here's my create table, a pair of parentheses. I like to put each field on a separate line. Lining up really helps make it easy to see what you're doing. I have the check constraint here. And then below this, I have a constraint that's not defined on one field. So the last field defined is sales price. An additional constraint is added, and I've given that constraint a name of check date acquired. And date acquired must be before you sell it. So then I execute it, and this turned out okay. So let's expand the test database over here. And you will see in Object Explorer, here is my dbo.transtest. So I called this trans test when I renamed it. And if you expand here, you will see here are the columns that we've added and some information about the columns. Numeric data type, by the way, is the same as decimal data type. And here is my key. Now, because I did not give a name to my primary key, SQL Server gave it this odd name. So there is a lesson. If you do want to be able to access your primary key, you probably want to name it yourself. And then here are my two constraints. So one is the name I gave, check date acquired. The second constraint is this field level constraint, which I did not name, and again, some odd concatenation of values there. And you will notice that because we have created a primary key, it is indexed on the primary key, and this is always true. Notice the word clustered. It is a clustered index. Normally, when you retrieve records, multiple records from your table, it's normally going to be sorted by the clustered index, which by default is the primary key. You can only have one clustered index per table. So that's what clustered means. Hey, what are you going to sort by? Usually, if you don't indicate, it's going to be by primary key. You can always retrieve records and use an order by clause in the SQL select statement to make it whatever order you want the output to be in. Okay, let's take a look at how you would create a table, okay, using the Object Explorer. So I'm going to go to Test, then I'm going to go to Tables and right mouse click and New Table. So let's say I wanted to create a customer table and I wanted that customer ID. And it's going to be an int. Okay, and I'm not going to allow nulls. It's going to be the primary key. And I want it to be the primary key. So do you see up here? I can set the primary key right there. So that indicates very much like access if you've had access before. Now I'm going to come down here to properties. And I can set column properties. These are similar to the constraints when we were typing the SQL. So I can set the column properties here. And here's where you can give a default value. And what I want to indicate is the identity. Okay. And is it an identity? Yes. It's going to be a surrogate key. And I'm going to start at 1. And I'm going to increment it by 1. So all those values that we keyed in the SQL statement, you can also do here. So the customer has a last name, and I'm going to do a varchar of 30. And I'm not going to allow nulls. And so you would pull in all your data. I will stop with first name. You get the idea of how to do this here. Okay. And so setting your fields and your properties based on that table you create after the ER diagram. You thought through what your tables are. Okay, and now when I go to close this, or if I click the Save button, it's now going to prompt me for the table name, and I'll type customer. Okay, so you will now see if I right mouse click on tables, I can do a refresh, and I now see the customer table with similar items too. Okay, so now that I have a customer table, can I relate these two tables? Can I relate my trans test table with my customer table on the customer ID field? That should be the common field. So I'll go to columns, and you'll see there's a, well, I don't have a customer ID. I got to create the customer ID and relate them. So how would I do that? Well, the table already exists. I need to be adding this foreign key to the trans test table. You will be using the alter table command. Okay, so here's my altered table. Trans test is the name of the table. I'm adding a field called customer ID. The data type is int, and there's my constraint. It's going to reference the customer table, customer ID. Let's go ahead and execute that, and you will see that it was correct. Again, if it's not correct, you're going to get a red message here. SQL Server Management Studio tries to tell you what line number was an error. And of course, the more experience you have in looking these error messages, the easier it is to decipher what you've done wrong. Okay, so I'm going to show you one more thing. Okay, so let me show you this thing called database diagram. Now, when I clicked on database diagram, this is going to happen to you. This is not an error. It says a message like this: do you wish to create them? And we're going to say yes. Okay, so now I'm going to create a new database diagram, and I'm going to indicate to add both tables, and you will see that because I've already done the alter table command and joined customer ID to customer ID, you see a link between these two tables, and you can look at the properties of that link. Okay, so I right mouse clicked right here on the line. That is the relationship, and it's indicating the name of the relationship. And I have not indicated what to do if I delete. What should I do if I delete a customer over here? Should I delete the transactions? No. And right now it says no action. I'll say no, set it to null over here. So if I delete customer 3 here, all the 3 transactions will be set to null according to that rule. If I change 3 to 9, I'm going to change 3 to 9 here. That's what cascade means. Okay, enforce foreign key constraint is almost always a yes. Very seldom is there enforce foreign key constraint is that referential integrity. It's almost always a yes. And here I have, as I expanded table and column specification, I see that customer ID in trans test is related to customer ID in customer. So you can set all these up using SQL, and even though you see that you can also work in the GUI to do this, I want you to use the SQL. SQL is good practice. SQL is what I want you to learn and what you will put on your resume. So I do have a lab that I want you to do, and in the lab I want you to copy and paste your SQL. I'm going to ask you to create some tables. I do need to do one more thing here, and let's say I've identified last name as an index. So an index is an object, and to create any objects, you do create and the name of the object you're going to create. Now, I've seen prefixes for index, so IX for index. if you like to use prefixes for your object. I've seen NDX as a prefix. So I'm going to call this So I'm going to call this, the name of this prefix, IX underscore customer last name, because I'm indexing the customer table on the last name field. Okay, so I've created an index, and I've indexed on customer table, last name field. And so you will do create index, you make a name for your index up, on, and then the table name followed by the field that you want to index on. Over here I've expanded indexes, and you see there's the name of my index. It is not unique. So you would do this for secondary keys. Notice it's also not clustered. You can only have one clustered index. So let's do one more. You may also index on multiple keys. So if you wanted to index on the entire name, you can do last name, first name, which is often you will have reports sorted by last name, first name order. So that's an index you could create. And I'll change the name of this to customer name. And you'll see that that has been created. I'll come over here and refresh. And there's the customer name index. If you've identified a candidate key is unique. So I might have in the create unique index, social security number. If I happen to have a social security number field in here, we know social security numbers are unique, and I could put the social security number in here. However, if I turn the IntelliSense on, I'm right mouse clicking and turning the IntelliSense on, you'll notice it says that that's not a valid value because I don't have social security number in here. But that would be an example of a field that you identified as a candidate key, and you're not going to make it the primary key, so you would use the unique constraint. Okay, so we got Lab 1 for you to work on, getting practice on creating databases in SQL Server Management Studio, creating tables. Hope you have fun.